first question I want to look at is on practice set 1. It's about 45, 45, 90 right triangles. We would like to have a really fast, efficient method, and there is one. Just want to give you a little background information on it to try to lead us into this idea. The concept is on similar triangles. They're same shape but different scale factor, and we're going to use this scale factor to our advantage to be able to move back and forth between the leg and the hypotenuse very, very quickly. We need to get familiar with the parent triangle ratios for every 45, 45, 90 right triangle, and those ratios I have written down here by the parent function, or parent triangle ratios. For every 45, 45, 90 right triangle, the legs have to be in the same ratio as a 1-to-1. Because the angles are the same measure, 45 and 45, the sides opposite them have to be the same length, so they are in the ratio of 1-to-1 no matter what they are. If you write the ratio of those sides, it will be 1. The nice part about every 45, 45, 90 right triangle is the fact that the hypotenuse will always be the square root of 2 times bigger than the legs. So if you know a leg, you simply take your leg length and you multiply it by the square root of 2 to find your hypotenuse. And the other flip side is accurate as well. If they give you the hypotenuse, then you can quickly find the legs by simply dividing by the square root of 2. So that's going to be our strategy. It's either going to be multiplied by the square root of 2 or divided by the square root of 2 to find the missing side. So in our parent triangle that I'm looking at, the 45s are 1 and 1, and the side across from the 90-degree angle or hypotenuse, which they'll either mark with the square or the box in the corner, or they'll put the 90-degree angle there. And the opposite side of that hypotenuse is the square root of 2. So in the problem that they give us in our practice set, they tell us that the leg has a length of 5. So if I'm given a leg, all I need to do to find the length of the hypotenuse is to take it times the square root of 2. As I said, anytime I need to go from a leg to a hypotenuse, I simply multiply by the square root of 2. So this has a length of 5 square root of 2. And that's a pretty fast and efficient method of doing this. Again, this all works because of the base concept, and I'm going to show you this, is that these two triangles are similar, and because the triangles are similar, their sides have to be in the same ratio and proportion. That's scale factor that we talked about. So if you had another type of situation, they don't always give you the legs, so this is a what if. What if they give you the hypotenuse? And we'll make it fairly simple here to start off with. They give you 7 square root of 2. If they give you the hypotenuse, you simply get to the legs by going and dividing by the square root of 2. A little thing that helps me remember, anytime I go from a short leg to the hypotenuse, or from the leg to the hypotenuse, however you want to think of it, but I go from a short side to a long side, I'm always going to use multiplication, and in 45, 45, 90s, it's going to be multiplied by the square root of 2. Anytime I want to go from a longer side to a shorter side, in this case it'll be from the hypotenuse to the leg, we're going to use division, and we'll have to divide by the square root of 2. Those are the two strategies I think that we can apply to this very quickly. So in the example that I gave you, if the hypotenuse is 7 square root of 2, to get to the leg, we simply take 7 square root of 2 and divide by the square root of 2. Square root of 2's will cancel, and that'll be 7. This strategy is pretty solid, doesn't matter what they give you, so don't worry. There's some different things that they can do to make it a little more difficult. First, they give you the hypotenuse as 12, and they ask you to find the leg. Simply take your 12 and divide it by the square root of 2. Now there's a little bit more math behind this. We're going to have to know how to simplify radicals. So to simplify the radical, we multiply top and bottom by the square root of 2. And that'll give us 12 times the square root of 2 on the numerator. And the denominator, if you want a couple steps in here, that's the square root of 2 squared, which is the square root of the squaring of square root can undo each other. They're inverses, so we'll get a 2 on the bottom. And it's 12 times the square root of 2. And now we can reduce our common factor of 2 and 12. So 2 will go into 12 6 times, and 2 will go into itself once. So our answer is 6 times the square root of 2. That's an example. One final example we could go with. It doesn't matter what they tell you that hypotenuse is. I'm emphasizing the hypotenuse because it's hard to go from the hypotenuse to the leg and from the leg to the hypotenuse. So we'll start with something like 10 times the square root of 3. Don't worry, no matter what that hypotenuse is, to get to this leg, you take it and you divide it by the square root of 2. Again, the analogy is, whenever I go from the hypotenuse to the leg, I simply divide by the square root of 2. We rationalize both the numerator and denominator, square root of 2, square root of 2. Whenever we multiply the square root of 2 times the square root of 2, I'll give you another analogy of this. This is the same thing as the square root of 4, square root of 2 times square root of 2, square root of 4. And this is 10 times the square root of, and the square root of 3 times the square root of 2 is the same as the square root of 6. But the square root of 4 is exactly the same as 2. So we got 10 times the square root of 6 all over 2, which gives us a final result of, if we take out a common factor of 2, 5 times the square root of 6. So that's my demonstration of how we can efficiently get back and forth between the leg and the hypotenuse of a 45, 45, 90 right triangle. Just quick multiplication or division by square root of 2.